Hi class, today I'm going to review solving exponential and log equations with you with number 1 and number 2 from this homework. So for number 1, we want to solve this equation for x, and I see on the left and right they are both exponential expressions. So when both sides have exponential expressions on them, I'm going to try to rewrite them with the same base if I can. So here I have 13, and I want to see by testing out some values on my calculator, what is another way to write 2197 or 2197. So after testing some values on my calculator, 2197 is equal to 13 cubed. So then once I have that, I'm going to simplify my exponents a bit more, because if I can get my bases to be the same, then that means my exponents are the same. So after distributing that exponent over, I have a base of 13 on both sides, which means now if those are the same, then the exponents 2x and 3x must be the same. 2x and 3x plus 15 have to be equal. And now we are solving for x. So subtract 3x on both sides. And then I have negative x is equal to 15. And x is equal to negative 15. So that's solving exponential equations if I can rewrite them with the same base. I could also do this another way. I could also do this by using inverse properties on both sides if I want, and I should get the same answer. So if I did a log base 13 on both sides, I'll have this, and then the log base 13 and base of 13 here, they would cancel out, so that all I have left here on the left side is 2x. And then on the right side, I can use the power property and bring this down. So that we have something like this. I can put this into my calculator. And if I put that into my calculator, I'm going to get 3. And then we end up getting a similar algebraic expression to what we got before. And then if we go through solving for x, we will get the same answer we had earlier, which is x equals negative 15. So there are 2 different ways you can do this. And there may be other ways as well, as long as you are getting the answer of negative 15. Hopefully it's a method that does work. So that was solving an equation with exponentials on both sides. Let's look at number 2, where we have a log on one side. So if I'm solving a log equation, I do want to get the log alone first. That's this part. And there is a 2 in the front. It's multiplying, so I'm going to divide both sides by 2, which is going to leave me with log base 2 of 2x minus 1 equals 5. The purpose of getting the log alone is so that we can undo the log by using that inverse property. If I have a log base 2, I'm going to exponentiate both sides with a base of 2 so that that gets undone. And then we can write 2x minus 1, that's what's left over. And then here I have 2 to the 5th power, which is equal to 32. And now we can go ahead and solve for x. And our solution is 33 over 2. Or in decimal form, you would get 16.5.